Hello, everyone. My name is Justin Luck. I am the program manager for Azure Container Instances. And today, we're going to have about 20 minutes to talk about why ACI is the easiest way for you to run containers in the cloud today, and why you should use them in contrast to something like AKS, like a Kubernetes service, or a service fabric, and things like that. So let's start off with saying that you're all at the right session. So there's a really big opportunity right now, especially for containers in the cloud, because Gartner believes in the next few years, we're going to see over half of enterprises running mission-critical, containerized, and cloud-native workloads in production. And so that's a 10x increase over what exists today. And that means there's a lot of opportunities for you to be at the spearhead of this modernization, as well as join Azure on this journey as we start to containerize all the things. And so, can I get a quick show of hands? Who here has used containers before? Oh, nice. Who here uses containers in production? That's still pretty good. OK, so who here has tried Azure Container Instances? All right. That's not bad either. OK, so why containers? For the people who don't use containers and don't have them in production, there's a few special values that containers provide over virtual machines or functions as a service. And so containers aren't meant to replace either of those. They're simply another tool in your toolbox for whenever you have a problem that needs to be solved by software. And so one of the values is speed. And so in the virtual machine world, you'd have to boot up an entire operating system for your host. And in a containerized world, you don't need to define that yourself. You can containerize your application and user space, and this means it's a lot simpler for you in terms of overhead. And so the second component would be simplicity. Being able to modularize large applications into singularized containers is fantastic. So an example would be batch data processing. So when you extract, transform, and load data, being able to dedicate a container to each step in that process lets you scale out bottlenecks if that occurs. So let's say you pull a lot of data and extracting takes the longest time. You can scale out the extraction container, which means it's a lot easier for your team to manage and update. And then packaging. So having to wonder, do I have my dependencies all packaged in with my application? Do I have my binaries and libraries? Being able to specify all of that within one Docker file makes your life much easier. And so we're going to bring the best that Microsoft has to offer to make sure that we have the best services, which means we're going to bring Clippy back, and everything is going to work perfectly, and you won't need anything else ever. So if you want to run a single container, Azure Container Instances is the easiest way for you to do so. And so this enables you to run containers without ever touching a server. And so if you run containers today, you probably stand up your own virtual machines, install Docker, and then handle the lifecycle of the VM so that your container is happy inside of user space. But in ACI, you can say, hey, I have my Docker image. I just want to deploy that. I don't want to muck about virtual machines. And you can do that. You can say, hey, Azure, take care of everything under my container, and we'll do that for you. And so the second component is we want you to see containers as a compute primitive. The way that you see a virtual machine today and the way that it interacts with RBAC, the Azure portal, the Azure CLI, we're going to make sure the containers have that same experience for you. And so on top of that, we're going to let you define your own configurations. So instead of going by a VM configuration SKU set, you can say, hey, I need exactly one CPU. I need exactly 1 gig of memory. And then we're going to bill you per second for each of those resources that you pick. And then the last component is we'll provide you secure hypervisor isolation for each of your containers. And so this is the same security model that you're used to with virtual machines, and we'll make it familiar and reliable in the same way for containers. And so let's stop talking about PowerPoints, and then I'm going to drag over this browser. And then we're going to hop into the Azure portal, which hopefully everyone here has seen once or twice. So I'll open up the Azure Cloud Shell, and I'll type az container create. And so I'm going to define one CLI command to deploy a container. And so I'm going to specify my resource group, which is this test resource group. I'm going to specify a name. And today I'm going to deploy a quick Mario game. And then I'm going to deploy my image. And I'm going to come over to Docker Hub. And so this is a public container image registry where I can simply copy paste the container image. I'm going to set an IP address so that we can actually go play the game. And then I'll set a port to be opened. And so that's just one simple command. And then this will be kicked off. And this is going to call the container resource provider that lives within Azure. And then we see that the request succeeded. So let's go into the Azure portal and take a look at it from a GUI perspective. So here's the Mario container that we just deployed. Let's hop in here. And so here we see the CPU starting to spike already. So we have integration with Azure Monitoring so that you can check, hey, what's the CPU utilization? What's the memory utilization? How's my container looking from a health perspective? And so let's go ahead and copy paste this IP. And I'm going to hop into the Containers tab where I can refresh. And then we see the image is still pulling. But we can go in here and check the properties. We have our image name, the port we opened, and then we have a default configuration for 1.5 gigs of memory and 1 vCPU. And then let's hop into our logs to see if it's still loading. It is. So let's refresh. And here we see we've created and we started the container. This has pulled all the bits from Docker Hub, slapped it onto an Azure container instance that we've stood up for you. And we can see the logs. They should be spitting out Apache logs now. And so it actually doesn't even stop there. We have rich functionality for things like exec. So if you're familiar with Docker, this is the same as Docker exec. And so this means I can execute arbitrary commands within a live running container, which is great for debugging. So I can do an AZ container exec, specify the resource group and the container, and then let's do a bash terminal. And so this is going to bring me into a live interactive bash session with my running container. Here's all of my application logic. And then I can also type env to see all of the environment variables, or we can see what version of Tomcat we have running and things like that. So let's open up a new browser, hit port 8080. And then this will bring us to this Mario game, hopefully. And so we support any Docker-compatible registry, so you can use an Azure Container Registry as well. And so this is going to give you the best-in-class performance, because then you can start to co-locate your registry with your container instances and vice versa. And so let's come back in here. Looks like we're still resolving. There's no clear. Let's go ahead and exit that. It's network resolution. All right. We'll let this spin a little bit more, but I actually have a backup. So let's go to Hello World. And so here's the same application. So you can play Mario if you want. Let's come in here, and then we've got like 10 minutes left, so I'm going to keep playing Mario, and then you can come ask me questions later about Mario. So let's get, oh, there we go. Now it resolved. And so let's get back to the deck. And hopefully that showed you how easy it is to deploy a single container if you want. But we also support scaling out. So if you want to run tens or thousands of containers that don't need complex service discovery or self-healing, then we can do that for you. But if you want something like self-healing or auto-scaling or things like this that are inherently built in, you want something like a Kubernetes. You want an orchestrator like Service Fabric or Kubernetes, which has all of this complicated logic that lets you manage and orchestrate containers at scale. And so what you just saw is a quick view around why you might want to use ACI specifically, though. So one, all I did was point you to a Docker image. You never touched a VM, so infrastructure in that perspective is invisible. If you want to burst out workloads, you don't want to have to worry about the overhead provided by all these new VMs. You just want your container to run. And so that's what we're going to enable for you. The second aspect is microbilling. So since we bill by the second, this means you can get a higher compute utilization than you would with VMs. So if I have a process that runs maybe an hour a day for like a week out of a year, then I'm not going to want a VM dedicated for that. I can instead deploy a container exactly when I need, get 100% utilization, and tear it down when I want. And that's part of the benefit of having immutable infrastructure, having these modularized logic components packaged up as a container. And then the last component is that modularity, so being able to scale out certain areas of logic that might become bottlenecks. And so what else can I build with ACI? You know, maybe I don't want to just deploy Mario games for the rest of my life. I don't know why you wouldn't, but data processing is a great example. So the ETL example, like I mentioned, you might need to extract, transform, and load logic into a durable store. Containerizing each component, if you need that flexibility of a container, is a great option. So I want to use my own language for the runtime. I want to use my own open source libraries. A container is a great format for you to do that. And then event-driven applications. So this infrastructure is classically used with functions as a service. So Azure Functions is the best route for you in the typical event-driven infrastructure. But if you want to run a process that maybe takes an hour, running a function for an hour might not be your best route. And in that world, a container might be the right route. So you can actually call an Azure function to deploy an Azure container, and that'll do the heavy lifting for you. And then on the last bit, there's elastic bursting. So we have built-in integration with AKS so that you can actually burst out in a Kubernetes cluster running with just VMs into ACI so that you have this mixed world of managed containers, but also VMs where you might want to configure at that level. And so here's a really quick example of a very simple event-driven architecture with container instances. So let's say you have some kind of web front end. It could be hosted in Azure Web Apps or a container or a VM, whatever you want. And that submits a job into a queue. So this queue could be an Azure Service Bus or like a generalized Azure queue. And then this is going to be basically hooked into Azure Functions. And so for the lightweight things, Azure Functions can go and do those jobs. But if you have a heavier process, the Azure Function can start up a container for you on demand. And then it'll do the heavy lifting right out to something like a durable store if you want. And then you can tear it down. So container instances support concepts like restart policies so that if my container exits successfully with exit code 0, the container will just stop billing, and then it'll just terminate. So that helps you manage your costs a little bit as well. And then really quickly on the AKS front, raise your hand if you are familiar with Kubernetes. Wow, nice. So in the typical Kubernetes world today, if you are the developer or the operator, you're going to be deploying pods through the Kubernetes control plane, and these are going to get scheduled onto VMs that already exist in the infrastructure. And this means that you are either going to have just enough pods running within all of these VMs, or you're going to spin up new VMs in response. And so ACI has the opportunity to come in and say, hey, if you don't have the resources already created and provisioned, just spin them out into Azure Container Instances, and we'll spin them up in seconds, and then we'll satisfy that workload that's meant to be bursty or transient. And so we have something called the ACI connector and the virtual kubelet project, which if you're interested in, swing by our booth, which is like over there with containers and microservices. We're happy to talk about that. But this enables a world where you have a mixed workers inside of Kubernetes. So you have things that can be deployed on virtual machines if you have steady state workloads. Maybe it runs for a whole month. You want a dedicated VM. Maybe you have hardware dependencies. You want an FPGA or a GPU that you have in your own cluster. But if you have bursty and transient workloads that are just working within the concept of a container, let them spin out into ACI. And the ACI connector is built in so that you only use the Kubernetes control plane. You don't have to learn a new API. And this allows you to keep and maintain your existing infrastructure. So really quickly, what's next? So today, you can assign a public IP address and a DNS name for your containers. And we're currently working on letting you join container instances into virtual networks. And so this is expected to land sometime mid to late this summer. And so this is the highest priority for us right now. But we're also working on more regions for you. So today, we're available in 6 regions, and we'll be doubling this within the next month. Log analytics integration. So you saw that you can pull your logs via the API, but you might want to cache them. You might want to query them with specific queries you want to write. And we'll make sure that you have log analytics in a first-class fashion. And then we're going to be supporting things like container health probes, so liveliness and readiness nodes, so that you'll be able to more quickly understand which containers are ready and willing to do the work that you need. And then support for things like secret environment variables to make that process of passing secrets and creds to and from containers a lot more easy. And then finally, we announced cheaper pricing with the announcement of the general availability a few weeks ago. And so this is effective on July 1st. And so what we've basically done is removed the flat rate to create containers and basically cut the memory cost by a little bit more than half. And so this hopefully opens up new options and new use cases for when you might want to use ACI. So on that note, I would encourage you to go deploy and go learn. I hope you saw that it was relatively easy to deploy a single container. So we have tons of collateral, a lot of great videos, and then, of course, we have our booth over there where you can talk to myself and my colleagues about when you might want to use it and what the best practices are. So on that note, thank you all very much for coming. It's been a pleasure.